Hello, I'd like to welcome you all to this video lesson in which I try to take my time to go to the basics of the chip itself, which in this case is that Megathit 2, and to try to show you some examples on how we apply the basics. Okay, now the first thing we need to understand is that we need to look at that mega chip itself, which I'll call this is the Atmega 32, right? That's the one we're dealing with in this case. Now, it's very much important to understand that the Atmega 32 is composed of the following ports, right? So first of all, we talk about ports in this lesson, and we'll see how we can program the ports. And then later on, I'll try to talk more about the other memory locations that we have within the chip and other features, of course, that would come with the chip. So this will be lesson number 1, just to get you quickly into the concepts. So the first thing we need to understand when we talk about that mega ports are these are the ones that we see right here, and they're about all of these ones that you can see here, and there are also ports that you can see here. But it's very much important that ports are found actually in families. So for example, we have port A. In this case, port A is composed of port A0 to port A7, right? And we have also port B. Port B again is composed of port B, which is B0 to B7, right? And then we have port C. Port C again is the same as I speak, like C0 to C7. And then we also have port D here in general. Of course, I may be speaking like this, but if you look at the chip itself, it's actually, they may be held in their specific locations. But right now, suffice to say that we have this is port D, for example, and port D0 to D7. So now, how do you begin to talk about ports? So now, whenever you are programming the ports in Arduino, in the Atmega 32, it's very, very much important that you understand things that are associated with the ports. So for you to successfully program the ports, it's very important that you appreciate how these ports are actually used. So the first thing that we need to talk about in this lesson is the ports of the Atmega 32 itself. So let's try to talk about the port itself and how the ports are actually configured. So in this case, I mean port A, port B, port C, and port what? Port D, right? Port D, right? So now, for every port that you see with the Atmega 32, there are 3 things associated with the port. What are the 3 things that are associated with any port? I'm going to list them down. They are actually, we associate each port with the following information. So the first thing that we talk about a port is the data direction register. I'm saying DDRC, but in this case DDR, data direction. And we also associate the port with the port itself, the word, and we also associate the port with the pin. Okay, so these are the 3 things that you need to appreciate whenever it comes to programming a port of the Atmega 32. You need to appreciate that the port has got the data direction register, and the port has got the port register, and it has got the pin register. Now you have to appreciate the fact that the ports are the eyes of the microcontroller. These are the places where we can input data and we can output data from. So for us to be able to program, we need to understand these ports in terms of what I've just written right here. So now, for example, what is a data direction register? Now, a data direction register, according to the ATmega 32, this is what configures the port. It configures the port as either input or output port. Okay, so a particular port can be configured either as an input port or as an output port based on what we configure in the data direction register. Now, I want to make you understand that the data direction register for different ports like port A, port B, port C, and port D, they are named according to the port itself. So for example, we have DDRA. This is data direction register concerning port A. And then we have port A register itself, and I'll show you this. This is also the port register itself, which is associated to port A. And then we have also the pin A, which is the port register. This is also a register that is associated with port A itself. So this is very confusing. Yes, we're saying port A. So what's the big deal? Pin A, of course, DDR, but the port A, similar word to that one. But I want to mention that these three are the registers that are associated with every port. All right. Now, so if we talk about port B, we also have the same, like port DDRB, port B, then pin B, just like that also for this. But right now, let's just try to also look at a very, very important component on how is the data packed in a particular port. Because let's say, for example, if we look at port A, what I'm doing is also going to be related to port B, port C, and port D. So how is the data packed? So if we look at the port A rate, port A itself, and then we also try to look at how the information is packed, because port A is composed of 8 ports, all right? Because the word port A is the general word, but I want to mention that when you look at port A, we have port A0 to port A7. And if you look at the way these ports are referred to, you actually see that we have these 8 boxes right here. So you can think of this as the 8 boxes, and then you can say that if this is port A0, this is port A1, this is port A2, this is port A3, A4, A5, A6, and then we have port A7. So I want to mention here that the way we pack these ports, they're packed from right to left. So if you look at port A, so this is how port A is, and then port A, if I start from the right going to the left, that's how my ports are actually packed. So this is A0 to port A7. All right, guys, this is very important for you to always remember, because then we'll talk about how do we address the port, right? So for example, right now is if I look at how these ports are, I can also refer this to as the port register. This is now the port register. Now the function of the port register is to simply give the status of a port, right? What I mean is that when every port has got those three registers we talked about. The data direction register, which is responsible for configuring the port as either an input port or an output port. And then we have also the port register, which is also responsible to hold the value of a particular port. So I want to show you something right here. So if this is port A7 up to port A0, so if I want to write the statuses of these ports, or what these ports really hold. So for example, if this is A0 and I put a 1 in that port, then it means that port A0 contains a high signal, right? And if I put a 0 on port A1, it means that port A1 contains a 0 signal. So if I put a 1 here on the position for port A2, it contains. So if I put that, if I put that, if I put that, if I put so if I put also 1, maybe 0, so you understand, right? So if I talk about the port register itself, I'm referring to the that register that holds what a particular port holds within the port F family, right? So because now we have port A, which is composed of A0 to port A7. Now if I begin to talk to the individual ports, I can either turn on the bit or switch off the bit. If I switch off the bit of that particular port of a particular family, then it can either have a high status on it or it can have a low status. Now again, when I talk about the port A, I can also talk about the data direction register of that particular port. Now I want to mention here that when it comes to the data direction register, we are also dealing with the DDR A0 to DDR A7. DDR A7. So again, we have 1, 2, 3, 4, 5, 6, 7. So here is the secret, right? So every port is associated with three types of registers we've already talked about. We've seen there's the port A register, but then the port A register has got to hold the status of the individual ports like A0 to A7. And then we have the data direction register. Now, the data direction register, the function of a data direction register is again to give direction to a particular port. Now, we don't understand that yet, so I'm going to explain. So here is a point. So if this is port A0 and its status is high, and I'm going to put, let's say, for example, let me just put the data here. So I know that this is DDR A0, this is DDR A1, this is DDR A2, this is DDR what? Maybe 3, 4, 5, maybe 6, and then 7. So counting starts from 0 to 7. Now here, guys, there is a difference. Let's try to interpret the information here. It's very important that we do the interpretation. So when we say, whenever we write to the data direction register, this is a rule. Let's say, for example, on DDR A0, which is the data direction register for port A0, whenever I write a 1 to that particular data direction register, it means that I'm configuring that port as an output port. Okay, port. And whenever I write a 0 on a particular port, like for example here A0, of course I meant to give it a 0 here so that I say input port, but whenever you write a 0 to a particular port, it means you're configuring that port as what? An input port. Now it's very important that you understand that a 0 will mean input port and a 1 will mean output port. Now what these two information mean is two types of information. What these informations actually mean, they mean that if I have a port a port can have, like in this case, we can try to interpret what's going on. It means that whenever, for example, when I look at the port register, I see that a particular port has got a high status, all right? And then I can also see that for that particular port, the direction is 0. So now what does that tell us? That actually tells us that that particular port has got a high status. If I get a multimeter and connect to that port, I'll register a logical 1 or 5 volts. But then the direction, whenever we have a direction 0, that means that that port is inputting information to it. So such a port benefits from being an input port and not an output port. Remember that these ports are bidirectional. They can either be configured as input ports or output ports. So what if you want to configure port A0 as an input port, then you need to make sure that you write a 0 to its data direction register. In this case, for example, on A1, we are saying that the status is 0, there's logical 0 volts, and then at in its direction we have 1. It means that this port is an output port, so A1 is an output port. So A2, there is a 1, it means the status is high, and this also actually means that this port is also configured as an output port. Now, very, very much important that you understand this, guys, because then when I give you an example of programming, you should be able to pick it. Now, there's also another type of register which is called a pin. Now, pin A in this case will actually, and I want to mention right here, guys, that pin A actually is also, of course, there is also pin A0 to up to pin A7, right? Pin A7. Now, this sort of register, in fact, this register is also associated with a particular port, but just remember that the function of this register is to simply hold exactly what the port registers has, right? So for example, if we have this, if the port register has got 1 0, so this one will also be 1 0 1 1, right? And 0 and 1, exactly the way we see here. But I want to mention here, when do we normally use the port register? Now I want to mention the pin register, sorry. The pin register is a read-only. You can see here the data direction register and the port register are read-write, meaning that you can write information to it, and you can also erase certain information, and they can also read from it. But this guy is read-only, meaning you can read only information from the pin register, but the pin register is a reflection of what is found in the port register. Very important that you understand. Now, how do we use it? Why is it important? Well, you see scenarios. For example, if I want to read from a pin, I want to read from a particular port, I don't use the word port whenever I want to read. I mainly may use the pin register, because the pin register is read only. If I want to read anything from a port to know whether there's a high status on that particular port or low status, then I'll use actually the pin as a way to go. So now, guys, it's very important in terms of ports that you understand, and then later on I also have to go through the memory units, the memory components of the particular ports. I'll talk to you about that, but right now I just want to show you the ports and how we can quickly program them. Okay. All right, so now having looked at these three types of things, now when I talk about the port, guys, it's very important that you understand here I'm referring to port A, meaning that the same information applies to port B, port C, and port actually D. All right. Now let's try to see now how do we get information into the port. So for example, I have port A, right? Again, I have port A as the one that I've been referring to. And now we are saying that in this port, we have A0 to A7. And we are going from right to left. In other words, this is the least significant port. and this is the more significant port. Now your question that you may have is, so how do I get information to enter into the port? So if, let's say for example, I want to make port 0 as low and this one as high, all right, and this one as maybe high, and I have 3 which is maybe 1, and I have maybe 4 which is 1, 5, F5 which is maybe 1, or S6 maybe which is 0, and A7. So suppose that I want to take this information. Whenever I write these statuses like this, it means that I'm talking about the port A register, because the port A register will give us the status of a particular port. Now, how do I get information to be the way it is? So in this case, what's the interpretation? The interpretation is that this port A0 has got no voltage on it, it has got 0 voltage. This one has got 5 volts, because the logic signal we're dealing with here is 5 volts. This one has got 5 volts. This is 1, this is 1, this is 1, and so on. So how do I do it? Now, how do I get information through it? I get it through some assembly code. In this case, that's the one that we're learning. And guys, I'll be opening up to the assembly coding that will help us to affect the status of a particular port. But before I go to this assembly coding, and I would like to briefly talk about some registers, okay? Now, because these are the things that we use. Registers are what we use to work the assembly code with the port so that we affect the port. So I'm gonna need to talk about the register just a little bit, but I want to mention here that there is going to be a dedicated lesson on these registers as well, because there is need for you guys to really appreciate, but I'll talk about them in brief so as to apply them in the assembly code. Now, what are registers? Well, registers are like small storage memory units within your microcontroller, right? Now we'll talk about the microcontroller architectures again later on, but right now it's just to try to look at how to get you guys up and running to program. So now, registers are small storage memory units that are found within the microcontroller, and apparently there are 2 types of registers that you'll find within the microcontroller. We have what we call the general purpose registers, and we have got the special function registers. All right. Now, right now, about the special function register, we'll be able to talk about them later on, but let's focus on the general purpose registers, which is the reason why you want assembly code for. So the general purpose registers, these are registers within a microcontroller that range from register R0, in fact they're giving us R0 to actually R32, right? All right. So you actually need to understand that we do have within this microcontroller, we have these registers which are found within the microcontroller, and they are from R0 to R31, right? Now, in fact, is it R31 or R32? Should be R31. So there are actually 32 registers that are found within the microcontroller. So if I start from R1, I'll go up to R32, but if I start from R0, then I'll go to actually R31, right? But I want to mention, guys, right here that these registers, they are the workhorse of the microcontroller. What do we use them for? We normally use them for storing data within the microcontroller, and this is the easiest way in which the microcontroller can store data, retrieve data, and actually process the data without going out of the chip itself. Remember, later on when we talk about the chip itself, I will show you that the general purpose registers, the microcontroller cannot process any information whatsoever without going through the general purpose register. This is the type of architecture. We call it the Harvard architecture of these microcontrollers. We use the general purpose registers to be able to do whatever processes that we need to do. But right now, I want to show you that the registers from R0 to about so from R0 to about R25. Okay, about R25. These registers, these are 8-bit registers, right? 8-bit registers, right? So meaning that these registers can only hold 8 bits of information. Right? And then from R26 to R31, these registers are called the XYZ registers, right? Now we'll talk about these in general when we deal with, but right now I just want you to understand that the XYZ registers, 26, 27, 28, 29, and 30, 31, all right? These are 16-bit long, 16-bit long, right? Bit long. Now, 16-bit long meaning that they can pack 16-bit of information, and these can pack about 8 bits of information. Now 8-bit is what you see here, 1, 2, 3, 4, 5, 6, 7, 8, and these can actually pack about 16. And we'll talk about the XYZ. These are usually important when we deal with indirect addressing, and we'll talk about them a bit later. But right now, so R0 to R25, they are actually 8-bit long, and so these general purpose registers, we use them in assembly code as well. So now, if you look at now, let's try to address. So we've talked briefly about these registers. Let's quickly try to see how we can use how we can talk about the assembly in general. In short, let's try to look at the assembly code. Now, when we talk about the assembly code, then we need to address how do we, I still come back to my point that I have my port A. Suppose I have A0 here and there's a 1, or maybe there's a 0 up to A7. How do I input information into this? So there's some basic assembly code. Now I want to mention, guys, that assembly language, there's a lot of stuff about assembly language that you need to appreciate, but there's a lot of codes, that we need to learn about assembly language, but it's not all these codes that we use. Some of these codes we actually commonly use them. So the idea to get information to a particular port and give the status of a port like A01 and maybe 1 or 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. Maybe there's a 0 there. You guys, you understand, right? So suppose now I want this way to, to load information in this way. How do I do it according to the assembly language? Now I want to show you something. In assembly language, we can program the assembly. We can show the data to program. We can show it in decimal. We can show it in hexadecimal. We can also show it in binary. But it's very important to express the data in binary, because that way you'll be able to see better how your codes are affected. So the way to go about it, what is the first step? The first step is that load a binary digit, in this case, digit, into the register, then from a register, load the info or the binary digit, the binary into what? Load the binary into the what? The port. So these are things you need to always look at. So what we are doing is that we're loading first the binary digit into the register, Now in this case, we are looking at register R0 to R31, but I want to mention here that you see me use some registers, and I'll explain why these registers are going to be used specifically for certain assembly codes. Then from the register you load into the port, then you'll have affected the port. So for example, I want to pack this. So how do I pack it? So first of all, we have to get the binary digit of this. What is the binary digit? I'll show you. There's the way we write the binary digit. We start with a 0B. 0 means that's the way the Atomic 32 have taken to write their binary number system. So you start with a 0 and then binary. Then you pack this as a 0. In this case, I mean 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then 6. What is it? 7. So 1, 2, 3, 4, 5, 6, 7. I think there's one more 1, I think, somewhere. So we have 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, okay, so we don't, oh, sorry, let me just write this. So we have 0B, 0, 1, 2, 3, 4, 5. Okay, so 5. 1, 2, 3, 4, 5, 6. 6, 7. Is it 6? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we know. So when we pack this binary number, so this binary number is going to represent how information will be packed in this. So this will represent A0 and this up to what? A7. So how do we now use, let's now see an assembly code that will pack the information into port A0. Let's see it. So guys, it's going to be a bit, so for this introduction, once you pick it, in my next lesson, I'll show you how now I can, oh, come on, it's stuck. I need to add a new page. Okay, so really quickly, maybe let me just show you. So there is an assembly code. It's called LDI, and I'll explain. I'll write it just like this. Then I'll say ARA. Let's say I'll say ARA16 from these registers. I'll get ARA16. Then I'll say comma 0B. Then I'll get this one exactly the way it is. So I'll say 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then 0, 1. Okay. Now, whenever I write an assembly code. Now, guys, all these assembly codes of LDI. This is an assembly instruction which stands for load immediate. The instruction is called load immediate. Now, what does load immediate mean? Well, load immediate means that load this binary number into register 16. That's what it means. In fact, it's an instruction that loads a constant into a register, right? So whenever you have an instruction that loads, this is a constant, this is a binary number value which is a constant. Whenever I want to load information into a particular register, then I need to write it like this. Now remember, I said first of all you load the binary digit into the register, then from the register you load the binary into the port. So now, having done this, and try to maybe wrap, or maybe now it can accept a new page. Okay, that's good. So let's now try to see, since we've said that now we have to load into the register LDI R16, 0B 0 1 2 3 4 5 0 1. So we're loading this binary number into the register. Then there's another instruction, it's called the out. Then I'm going to say now port A, comma R16. So you can see what is on the left, on the right is being loaded to the what is on the right is being loaded to the left. So again, I'm saying I'm loading this number into R16, and then I'm outputting what is in R16. I'm outputting it to port A, right? That's what it means. Now guys, if you've done this, you actually see that for sure whatever is in R16 will be copied to port A. And in this case, since port A is a combination of port A0, port A1 up to, so we'll have A0 to A1. If you load it in that A7, then you are guaranteed that this one will sit here, this 0 will sit here, and exactly the way they are. So using this assembly code, we have a clear way in which now we affect the status of a port. Now what does that mean? It actually means that port A0 has got a high status, and it means that port A1 has got low status. It means port A3, port A0, A1, A2 has got high status, and then you can see here that port A0 will have actually low status. Okay, so that's exactly what this means. All right, so if now we try to look at how do we load the information within the data direction register, because remember there's two information that is very important that you need to supply to a port. First of all, you need to give the port its status. What does the port hold at a particular time? Does it hold a 1 or a 0? In this case, I'm talking about port A0 or port A1 and port A2 or port A7. Now, once you talk about the status, always remember now, the next thing you need to now discuss in your mind is that, okay, so I've dealt with the status of port. Another thing now that you always need to think about is the direction of the port. So now you want to have a clear understanding on the direction of the port. Now, what does that mean? Is this port an input port or it's an output port? So, for example, does the A0 have a 0 in its DDR? Does DDR A0 equal to 0? If it is equal to 0, then it means therefore that this port A0 is going to be configured as what? An input port. So let's, for example, so how do we again affect the concept of DDR? So for example, here we have DDRA, right? And we want to have the following code here, right? So let's say, for example, we want that port, we want to have such a direction. So if we have 0, 1, 0, 1, 1, 1, 0. So this is 1, 2, 3, 4, 5, 6, 7. And then we have Nichani 8. 8. So here we have 0, 1. So let's say, for example, we have A0 here. All right. So we know that if I put a 0 on port A0, then in the data direction register, it means this port is going to be an input port. This A1 will be an output port. This A2 will be an input port. So this will be what? The output ports. So how do we do it in assembly code? So we can say again the same, we can use LDI, for example, we can use the same register 16, and then we can load this number, we can say 0B we can say let's say we say 0, and then we say 1 1 1 1, right? So 1 2 3, and then we can have 0 0 1 0, right? And then we can output this to the DDR8, R16. Now this actually simply means that whatever I have done, again moving from right to left, it means that port A0 in this case is going to be configured as an input port. This one will be configured as an output port. This one will be configured as an input port. This one will be configured as what? As an output port, and things like that. So when you do that, it means that information now is packed from 0 or maybe 1, then 0, then 1 1 1 1, something like that, 0. This is A0, these two, or in short, this is DDR-A0. So this will represent port A0 as an input port, and we have DDR-A7. And so this is exactly how you are able to effect the direction as well as the status of a port just using one register. I've used R16, but I want to mention that the command LDI command works with registers from R0 to R16. I mean, somewhere there. All right. This is a command which is called the load immediate command. The load immediate command is an instruction, a lawful assembly instruction that allows us to write in AVRA Studio the how to load a constant into the register, and finally into its data direction register, the port, or into the port register, to give both the status and the direction of a port. Now real quickly, let's try to appreciate why do we have to make certain ports as input ports and certain ports as output ports. So if you look at that Mega32 and you want to have let's say for example we have two buttons. Let's say for example we have, I'm gonna say I have a button here, right? And then you have an LED here, for example, right? Now you can see here that suppose that this is port A0 and this is just maybe port A1. All right. Now guys, or it could actually be port A0, it could be port B1 or something like that. I don't have to talk about port B, port C, but if I talk about port A, it means the same information goes to port B, port C, and port D. So now here is an LED connected to this port. Now you can see here that we've got two ports. One port is connected to a button, all right, and another port is connected to an LED. So now in this case, we know that this port where we are connecting the button to benefits from being an input port, all right, because then an input port is a port that takes in information, right? Meaning here when the button is pressed, we need to have a way of knowing that the button is pressed, so we'll get information from the button. And then this is an output port. It's an output port because then whenever for this LED to light off, it means that this port A1 should give out the 5 volts to the LED. So this becomes an output port. So that's the reason why these ports, you need to configure them either as input ports or as output ports, because then you need this to understand that. So if we say that, all right, so let's say for example now we say that now how do we pack this? So if they were packing through the LDI, then you know that if this was your port A0 A0, and you have to think about the status and the direction, right? So if now I'm dealing with just port A0 and this is port A1, right? Then I'm beginning to think first of all. So suppose this is now to do with my port register. I don't care about others. I'm more concerned on port A0 and port A1. And now I also need to look at what is the data direction register of these ports. All right, so DDRN. So here is the point. So port register. So port register has to do with the status, right? So I need to think, okay, what should be the status of port A0? Now I want to mention here, guys, that I'll just give you the status. So the status of an input port. Mainly we write a 1. I will show you the reason why in the next lesson. So I'll say that port A0, I'll give it a high status, all right? And port A1, I want to give it a low status because before the button is pressed, I don't want this LED to come on, right? So I'll give it a 0 status. And here I'll give this input port, I'll give it a 1 status for a reason that I'll explain later on. Right now, just showing you to understand the basic of how the direction and the status. So when it comes to the data direction now, so now here we need to think. If this is A0 and we are meant to configure it as an input port, then definitely the DDRA0 of it, and this is the DDRA1 of it. So the DDRA0 of it, which is this port right here, the DDRA0 of this port, would definitely benefit from being an input port because really we are connecting a button. So therefore here I'm going to write a 0 there because this is an input port. A0 is an input port. And then A1, I know that the DDRA1, this is meant to be an output port. So in the data direction register, I'll need to write a 1, right? So when I do this in the data direction register, then I'll have qualified what these ports are. I want to mention here that when you get an ATmega chip, an empty ATmega chip, these ports can be configured either input ports or output ports. If you don't define your data direction register, then you have a problem in running the chip because then the problem that will be there is that the ports do not know themselves whether they're input ports or they're output ports. Then you yourself, you have to configure it through your assembly code. Now guys, for this first lesson, I'd like to end right here. In the next lesson, I'll actually now show you how we do the programming after I've given you the programming of the ports, after I've shown you how this actually works. Now I'd like to thank you so much for viewing, and I'll see you in my next lesson.